Hello UTEP students. Today we are going to work on a chapter 14 homework problem. This is on rate constants and activation energy. So let's begin with our problem. For a certain reaction, the frequency factor A is 2.8 times 10 to the 9 per second. And the activation energy is 19.2 kilojoules per mole. What is the rate constant for the reaction at 78 degrees Celsius? Now notice this is Celsius and this is kilojoules, and for this equation we're going to be using the rate constant R, not to be confused with our previous rate constant that was for vapor. This one is for energy. So this one is 8.314 joules per Kelvin mole. So what you're looking at is you need to convert these two to even start this problem. So let's go ahead and go through the conversion. So K is equal to C, which is the Celsius, plus 273.15. And that without the 15 will go ahead and give us 351 Kelvin. And now let's go to the activation energy. This is in kilojoules. Usually when I think of kilojoules, I always compare it to kilometers. Kilometers are usually compared to miles, which are extremely big in the amount that we're working with. So I know that I'm going to need a big number. So usually I would just move the decimal to get to what I need. So once we have these numbers that are already converted, we can go ahead and go on with our process. Now let's go into the equation that we need to use to find the rate constant. Now the rate constant is equal to the minus frequency of, or multiplied by E, the one that you typically see associated with natural log. And from here, this E needs to be raised to the negative activation energy over the rate constant times temperature. So that's what I went ahead and did over here to go ahead and conserve time, is that I have the minus activation energy and the rate constant, or the constant and the Kelvin. I went ahead and wrote it over here. Notice that the negative sign is incorporated. Don't forget that. That's not a part of the variable, it's actually a part of the equation. And so once I did that, I put it in the calculator. Everything was with E, and you can go ahead and see that to get E, I just did second and E to the X, and that's where I would put everything in there. I collected negative 6.58 as my answer. And I'm not done there. I actually need to go ahead and go into using the actual equation up here. So I actually need to do the negative AE to the negative 6.58. Okay, and then of course for A we already have that. That is the conversion factor up here at 2.8 times 10 to the 9. So we'll go ahead and do that. 2.8 times 10 to the 9. And from here we multiply it. When you do this, be a little more neat, because you're going to need it to get a good answer and to know where you have gone wrong on any part of the equation. So right here, K is equal to. And so from there, once we do everything, once we multiply and we raise, your answer will be 3.9 times 10 to the 6 seconds per second. So for this, it was basically just finding your conversions and then being able to apply it to the equation that you have.